In section 2.3, we're looking at lines, and the first thing I want to talk about with lines is how to find the slope. The slope is the measure of steepness. So this black line has this angle, and that slope measures how steep that angle is. So if it's very, very steep, that's going to have a high positive number. And if it's not as steep, that'll have a smaller number. If it's going down from left to right, that's going to have a negative slope. Actually, I'm going to always go from left to right. I'm going to slide down to this other picture here. So when we have a slope that from going from left to right, always go left to right. So but my red one goes from here, and then if I go to the right, I'm walking uphill. So that means I have a positive slope. And again, if it's steeper like this, I'll have a higher value like 2, whereas this one would be like 1. This slope might be 1/2, something like that. But they're all positive. And then as that gets less and less steep, as that 1, 2, and then 1, and then 1/2 gets lower and lower, it actually gets to 0. That's what this horizontal line is. So there's no steep. I'm just walking along a sidewalk from left to right, and there's no slope. There's no steepness. So that has a slope of 0. And then if I keep going, then it starts going negative. So if I go down a little bit, that's like -1/2. Down a little steeper, that's like a -1. And down even steeper, that's like a -2. So this blue one going from left to right is going downwards. So it's a negative slope. So that's falling from left to right. And then finally, it can get bigger and bigger and bigger and bigger and bigger and bigger until it gets to be a vertical line, which in this picture is purple. This vertical line, the slope is undefined. Imagine you're walking up a hill, you have a slope of whatever, and then all of a sudden there's a cliff. And if you're walking along, then you just fall. There's no way to define that slope. You're just falling, and that is undefined. Let's look at how to calculate slope, and then you'll see why that's undefined. All right, so we talked about, I don't know if we talked about, let's start over. So we're doing rise over run, that's my key phrase when I think about how to calculate the slope. Always going from left to right. Between 2 points, I'm going to go from this purple point to this red point. And to get from that purple point to the red point, I rise 2 units, and then I run 3 units. So take your elevator up first, and then go to the right. If this line was facing down, my rise would really be going down, so it'd be a -2. But my run is always positive because I always go left to right, so I'm always going to the right, which is positive. But my rise can go up or down. So think of you're taking your elevator on your rise, and then you get off the elevator and take a jog. Okay, so rise over run. So I'm gonna, we do have a formula right here. And the most common mistake in a very important thing to keep track of is your order of y1, y2, x1, x2. It doesn't matter which point you call x1, x2, y2, y1. It does not matter which point is 1 and which points are 2, but it does matter that it's the same point, that it's consistent. So I like to label it this way, like thinking of this as one pair, one ordered pair, and then this as the second ordered pair. So it doesn't matter which one comes first, which one comes second on one side of the fraction, but vertically be consistent. So use 1 point for the purple and then 1 point for the red. So let's calculate slope. So I'm going to show you that it doesn't matter which one's 1 and which one's 2 as long as you're consistent. So I'm going to switch them around I'm going to do 2 different formulas. So let's do the purple and the red, the purple point and the red point. So that purple point is -2, -2. And the red point is the x is in the denominator and the y is in the numerator. And I get, when I calculate that, I get -2 minus 0 is -2. And in the denominator, I get -2 minus a -1, which is -2 plus 1, which is -1, which equals 3. Whoops, no it doesn't. That's silly. 2. All right. Now what if I had switched the order? But as long as I'm consistent, I should still get the right answer. So this time I'm going to start with the red points. So I have the 0 and the -1. X is in the denominator, y is in the numerator. And my purple point is -2, -2. So now I have 0 minus -2 is +2. And -1 minus a -2 is -1 plus 2, which is +1, which again equals 2. So regardless of the order, it doesn't matter as long as I don't switch the order within the point. So as long as I'm consistent. So let's say you made a mistake and you actually wrote, you switched it and you did, let's do that in black. You said m equals, and you did your little bar and your minuses. And for the purple point, you did the y over here and the x over here. And you did the red point, you did the y over here and the x over here. See how it doesn't line up? That's not one point looking at it vertically. So I might get a wrong answer here. So I get -2 minus 0 gives me -2 over -1 minus a -2 is -1 plus 2, which gives me 1, which is a -2, which is the wrong answer. This is wrong because it's going to give me the wrong sign. And that error came because that is not from the same point, looking at it vertically. Okay, so a few minutes ago I said slope is rise over run, and then I gave you a bunch of x and y's. So let's look at what I really meant by rise over run. I'm going to erase this errorous one. We don't want to remember that one. We want to remember not to do that. So what do I mean by rise over run? So this -2 minus 0, that's really the measure of this height. It's a +2. It's going up 2. So 0 to 2. And so that's my rise. And my run is how much I go to the right. So that distance is going to be 1. So that's -1 minus -2 gives me that 1. So that the blue is my rise, the numerator is my rise, and my denominator is my run. If I'm looking at a graph, I don't have to get the formula out. I can really just count. Like let's do the blue point to the purple point, but always go left to right. So blue point to the purple point, my rise is 1 and then 2. So that's a 2 unit rise. And my run is 1 unit. The rise is positive. The run is always positive. So it's 2 over 1, which is going to give me a slope of 2. So I didn't have to use the calculation. If I have the graph, I can just count units and do how much am I going up or down, it's positive or negative, and then how much do I run to get to the next point.